Good morning. My name is Clinton Wong, and I'm here to talk to you about an alternate cookie tracking system called local shared objects and what its implications are for your privacy. So to tell you a little bit about myself, I'm a software engineer and I work in Silicon Valley. And I've written 2 O'Reilly books, Web Client Programming with Perl and HTTP Pocket Reference. So to start off, this talk isn't really about anything new. In fact, this is something that's been widely known about 3 years ago. But in the hallways of Silicon Valley, when I talk to my coworkers, unless you're a security researcher, this is actually something that not a lot of people know. And if people writing software don't know this, chances are just the regular user doesn't know about it either. So I decided to do this talk to basically have a public service announcement to tell you something you should know, but you probably don't. And because you don't, it might hurt you. So if you look at this Wikipedia entry for local shared objects, it tells you basically exactly what I'm going to be spending 20 minutes telling you about. But I'll explain it in a little more detail so you can sort of understand and manage it better. And then after that, there are a few other things I'd like to tell you that are not related to local shared objects, which I'm going to refer to as just LSOs from now on. But also, it'd be useful to know, and once you know, it'll help your privacy. So a quick survey. How many people know that browsers have something called cookies and that websites can use them to track you? Okay, a good number of people. How many people know about Adobe Local Shared Objects? Okay, some other people too. All right, so before we talk about local shared objects, let's talk about first what the established system already is. HTTP cookies are what people refer to commonly as just plain cookies, and it's something that is well documented from the Internet Engineering Task Force, and there are various documents that describe how the protocol between your browser and your server work, and also how cookies work. So let's take a look at that. If you've read any of my books, you might have noticed that I like to explain at a protocol level how things work. So let's take a look at when your browser goes to google.com. First, it figures out, using DNS, like where to find google.com. So it gets the IP address of the main Google web server. And then it'll establish a TCP connection to port 80, and it'll send this over that connection. It looks pretty simple. So there's the first line is a request, and then the rest of it is a description of what the browser is and what kind of content it can accept and who it thinks it's talking to and things like that. And the Google web server will reply with a response, and the first line is basically a status code and also a bunch of information about itself. The one thing to note here is the bold line in the middle, and it says set cookie. And then there's a name-value pair. It's a really long string, so I've truncated it, but this is something to remember for the next slide, because when you talk to Google again with your web browser remembers that name-value pair and relays it back. And that's how websites can have a session to associate your request with you. It's a unique way of identifying you, and it's stored in your browser. So browsers let you manage this. Here's a screenshot from Firefox 3. And in the middle, you can see that you can tell Firefox to accept or deny cookies in general, whether to allow or deny third-party cookies, which are cookies that come from websites that you didn't explicitly go to. For example, add websites that are referenced from wherever you happen to be visiting. And you can also set the expiration policy. The web server will tell you what the expiration date is, but if you want to, you can say, well, clear all the cookies when I quit Firefox. And likewise, you can look at each individual cookie, and there's usually an option in your browser to just clear all private data in general. So your browsing history, the username and passwords that it remembers, everything, including cookies. And on top of managing cookies in your web browser, you can also filter them using web proxies, you could. This is a common scenario that that corporations use. Chances are there's a proxy server in your firewall, and if you're inside a corporate network, you have to explicitly use it to get to the internet at large. They generally don't filter cookies, but they could. If you care to filter cookies on your own and not really use your browser to do that, you can use something called Provoxy, and the website is at the bottom of this slide. And basically, you can run your own web server on your own computer and tell your web browser to use it, and then you kind of don't have to care what your web browser is doing, because Provoxy, you can configure a bunch of policies to filter or allow cookies to go through it to the website you're talking to. Okay, so now let's talk about local shared objects. So Adobe developed something called Flash, and there's a Flash plugin that most all web browsers have. And it's pretty much something that a lot of websites use. So you can't really turn Flash off, otherwise there's some functionality that you're missing. This is how YouTube works, how you watch video. This is how Pandora works, so you can listen to music using their website. This is how ads are delivered to have rich media. And so this is an interesting and useful thing to have around, and it's something you can't really turn off. And Flash has its own cookie system, similar to HTTP cookies, and it's called local shared objects. So the interesting thing about this is that these local shared objects are not cleared when you tell your browser to clear private data or to clear your cookies. In fact, unlike regular HTTP cookies, there's no expiration for them. So if you don't know they're there, and it looks like a lot of people don't, then they're just there forever. And, well, that's bad, because you might be clearing your browser thinking that everything's actually cleared, but the website developer has a way to actually permanently store stuff on your web browser and use it forever. So maybe your privacy is endangered in some way because you think you've cleared it and it actually has not been cleared. So just to drive the point home, in Firefox, this page does absolutely nothing. And this clear private data in Firefox doesn't do anything either. And when you try this with all the different web browsers out there, Safari, Firefox, Camino, Internet Explorer, none of them know how to clear this local shared object from your Flash plugin. And companies know about this. So this is a 3-year-old article, but it basically says, hey, there's a company out there that's going to take your regular cookies and store them as local shared objects. And if you clear your regular cookies, well, it'll just restore them from your local shared objects. So this is a marketing technology. It's not clear how many people actually use this, but it's definitely out there. So it's possible that any website you visit could be storing data permanently on your computer simply because you don't know it's there. So it's actually not that bad. How do you fix this, right? So how do you get those configuration panels for Flash to configure your local shared object policy? Adobe does have a page that explains how to do this. So the URL is here. You don't have to write it down because this presentation is on the DEFCON CD, so you can just look at it later. But basically, if you go to this URL here, then that URL has a Flash app, and then when your browser looks at that, the Flash plugin will load it and run it, and there it is. So here's this page that not many people actually know about. And you can actually sort of configure how your Flash plugin works. And clearly here, there's an option to allow third-party Flash content to store data on your computer. That's basically talking about local shared objects. You can configure the size of the local shared object, though chances are people don't really store that much on your computer, but they could. And likewise, if you visit this other URL, you can look at the individual cookies, if you will, and clear them or delete all of them. And if you've never realized that this is here, this might be a startling thing to look at. It's probably a very large thing. A lot of ad tracking companies and common sites like YouTube and in this example, Yahoo, right? So it's not very easy to filter these local shared objects. With HTTP, it's clearly defined in the cookie header and set cookie header, and the proxy can just can clear that and look at the website you're using and decide what to do with it. So I decided to log into Pandora, and I stripped a lot of the information out. But basically, Pandora will ask you for your username and password and store that as a local shared object, but also send it along to the web server because it needs to know what your settings are. And if you look at the request, it's that very last line, which I've truncated, and it's this really long hex string. And, well, for a web proxy, it's not really clear this is even a local shared object at all. It just looks like a post and some data. And so it's not very easy to really filter in any way. Likewise, the response from the Pandora web server looks like this. There's a bunch of XML data that it returns, and that's up to the Flash plugin to interpret. But really, from a proxy point of view, there's nothing really there that says this is also like a local shared object either. So it's not very easy to filter this. Okay. So having said all of that, now you know that they exist, local shared objects, and roughly how to manage them. And so you can clear them now, and you can turn off local shared object support and have a more private browsing experience. Okay, so what else is useful to know here? So I'm going to talk about things that are not local shared objects, but chances are you don't know about them unless you work in the security industry, and they'll be useful. So this is the Washington Mutual website. It's a regular screenshot. I've done nothing special with it. And, well, there's something wrong here. Does anyone know roughly what it is? Can you raise your hand? Okay, some people know. All right, so here's a hint. Okay, so this is that page again, and here's some of the HTML from that page. And, okay, so you're posting your username and password to an SSL HTTPS location, so that means you're sending it encrypted. So what's the problem, right? Well, the problem is, if you notice here, you just visit www.wamu.com. You're using HTTP. That's not using encryption in any way. And when you use SSL, there's something called a certificate, and that ensures that you actually are talking to who you think you're talking to. And the reason, and the fact that you're not using it means you don't really know you're talking to Washington Mutual at all. It could be that someone in the middle has tampered with the data. Let's say you're using a Wi-Fi connection, and whoever runs the Wi-Fi is malicious and decided to do some nasty hack here. So that means this regular HTML, they could have changed such that you're posting it to some arbitrary site that they want you to post it to. And while it may not actually log you into the Washington Mutual website, you've at this point divulged your username and password to some arbitrary place. Right, so that's bad. This is also something that's well known. It's documented 3 years ago. And basically, people who develop web services need to realize that when you have a login page, it has to be HTTPS, basically HTTP over SSL. And in my survey of the major financial institutions, they actually do get this. Washington Mutual was pretty much the only one that I could find. So people are catching on, but still, it's 3 years later. It's as with anything in security, it's a matter of awareness. Okay, so what's wrong with this? Chances are this is something a lot of people use. This is Yahoo Mail. It's really similar. So basically, this is something that was talked about last year at Black Hat, and there's a technique called sidejacking. On a regular trusted network, the data between you and Yahoo is pretty much private, but if you're on something like a Wi-Fi connection, well, everyone can see the traffic. And that means when you're communicating with, say, the Yahoo web server, there are cookies flying around and there's not any encryption here. And so everyone can see your cookie, which means they can actually use your cookie while you're still logged in. And that means they can impersonate you, they can do whatever they want as you when you're logged in. Google realized this is happening, and there's a special URL you can go to, https://gmail.google.com, and after you log in, your entire session will be SSL encrypted, so that problem goes away. With Yahoo and Hotmail, I don't know a solution for this. I tried looking. If you know, please let me know afterwards, and I'll update the slides, and the updated information will be on the DEFCON website. So that's pretty much it. I hope you've learned something about local shared objects and how to improve your own privacy, and never log into a financial institution or anywhere else where you care about your privacy using HTTP. The page must be HTTPS. And for your email, try to use something or pressure your current mail provider to have an all SSL session for your traffic. And that's pretty much it. Thank you.